What is nanotechnology? What is nanoscience? In this episode, Dr. Ramesh Raliya will explain to you the basics of nanotechnology and nanoscience and how one can pursue his or her career in nanotechnology. Dr. Ramesh Raliya is a research scientist at Washington University in USA. He has done extensive research in the area of nanoparticle technology and is having expertise in advanced functional nanomaterial synthesis. Holder of 5 patents for his nano-biointerface research, Dr. Raliya has received various international awards for his work in the area of nanotechnology.
Hi everyone, my name is Dr. Ramesh Raliya. I did my PhD from Janarine Vyas University in Jodhpur, and the subject was chemistry, and before that I did masters in biotechnology from the same university. So you might get surprised that why I did biotechnology and then the chemistry, because I wanted to choose an interdisciplinary subject that we call nanotechnology. Before moving to Washington University in St. Louis, I was working as a research associate in Central Arid Zone Research Institute, is a national laboratory for Indian Council of Agricultural Research, ICAR, in India. My research work was focused on nanotechnology, and nanotechnology is an interdisciplinary science. And when we call about interdisciplinary means the nanotechnology has background from chemistry, physics, biology, and the concept of engineering. So what is nanotechnology and what is nanoparticles and what this word nano basically is? So the nano refers to the particle or any structure which having dimension in between 1 and 100 nanometer. So now the question comes, what is 1 nanometer, right? So the 1 nanometer, so we know the 1 meter scale. So the 1 nanometer is 1 billionth part of that scale. So we cannot see the nanoparticle through our naked eyes. We need some sort of instruments to see these kind of structures and these particles. And the primarily or the common instruments that we call is an electron microscopy. Electron microscopy further can be like several different type, like transmission electron microscopy, scanning tunneling electron microscopy. So the different kind of electron microscopy based on application, but as a broader category is an electron microscopy. They use the electron beam instead of a light source. For example, in light microscope or a simple microscope that we use in our schools or in the hospitals might you have seen. So in light microscope we use source as a halogen lamp or a UV light lamp, whereas in electron microscopy we use electron source to see the small particles. So these small particles further can be of different type, different materials, different structures, and when we change their properties like physicochemical properties, when we change these properties, their application get different. So you might have now the question or the curiosity that where can I use these small tiny particles and how these particles affect me, or whether I am already using these small particles with my devices, with applications, or I am getting exposed when I am in the open environment. So let me tell you at the starting that you are already consuming the nanoscale particles, you are regularly getting exposed, and in fact every day when you come out from your home, and before leaving your home you do face massage, facial or facial creams or even sunscreens, they all have the small particles in nanoscale range. If you ever see the content, so there might be a content that they call it SiO2 like silicon dioxide or titanium dioxide mainly in the white creams or all kind of lipsticks and other facial creams that we all use for cosmetic purpose on our body. So they all have the small nanoparticles. Further, you might like the donuts. When we go to the restaurant, we ask the donuts, and sometimes you might see donuts have the white powder on that. And several times I saw that children are asking that I need more powder on that. And what is that white powder? That white powder is basically the silica nanoparticle and the titanium dioxide nanoparticles. And the other, so these are some, we call it engineered particle, and there are some non-engineered nanoparticle. We all like to go on a sea beach, and we all like the beach, like clean beach, and we go take a nice bath there. But did you ever notice that if you sit on the seashore or on the beach for a sun bath, and then you will see that with the time there are salt particles get deposited on your skin, because the sea water has a lot of sodium chloride, that we call it salt, and that salt particle get evaporated or they become the vapor, and they get deposit either on the surface of the soil, or the organisms or the animals sit there, including human who go there for enjoyment. So all the small particles get deposited, and if you scoop those particles from your skin and see under the electron microscope, you will see that all the small nanoparticles is deposited on your skin. So the same way, if you go on the road for walking, you see a lot of pollutions in country like India, China, where we have like certain cities in these countries have a lot of air pollution from the vehicle emissions. So what things coming through the vehicle emission is an small soot particles, the carbon particles, they come and get deposited on your skin. They enter through your eyes and through your nose. And recently, in many places on the globe, they introduced CNG, for example, CNG based vehicles to minimize the pollution. But you know, in CNG you can't see the carbon soot, you don't see the black smog, but because you don't see doesn't mean that there is no pollution. There is a pollution. The CNG generate very fine particles. They are in nanometer size range. We cannot see through our eyes, but they get deposited in our body, in our lungs, and they create several harmful effects on our body. Let me show you one more example. That, for example, we all use the batteries. Some use in cell phone, or when we drive the car, we have the batteries, and these days we also use battery based vehicles. So you might see that there are some cars, for example, a company Tesla in the United States, they have the car that one time you charge and then you can run for several hundred miles. And you often experience with your cell phone that with the time when you purchase your cell phone battery or your laptop battery, it charged for 6 hours or 8 hours or 12 hours. But with the time, after 1 year or after 2 years or maybe after 4 or 5 years, in case of there is some good brand laptop or cell phones, your battery getting die like within 2 hours or 3 hours. What I want to say that with the time your battery life is reduced. So do you think that we should create something that one time you charge, so your battery get charged in 5 minutes or 10 minutes, and then battery lasts long for 30 days. Yes, it is possible through the nanotechnology, and it is being happening right now in the laboratories, and the things will come into the market very soon, perhaps in next 2 to 3 years, I think, for the common man applications. So the same way, I mean, we have the application in different parts, and because of the nanoscale technology, earlier our hard drive, hard disk or laptop size was, you have seen that how big was their size and how heavy they were. But these days you can see that even thin like a paper, you can get a screen where you can work very nicely, like touch screen just like a paper. And your cell phone weight and size and gigabytes. I remember when I was in undergrad, I bought 500 MB pen drive, but these days nobody's buy that. And I'm not talking about 1950 or 1970, I'm just talking about 2006, when we were like just affording as a student like 1 GB or 500 MB pen drives, but these days we just buy in terabyte or like several hundred gigabytes. For example, if you passed class 10 or class 12, so and you passed with different subjects, like maybe with physics, chemistry, mathematics, or physics, chemistry, biology. These are the basic streams that we have. Or you might have optional with computer science, or you have some other engineering subjects like environmental science or agricultural science in some subjects, in some syllabus or some board examination. So what you need to do to study the nanotechnology or the nanoscience. So because I mentioned that nanoscience is an interdisciplinary subject, it uses the concept of physics, chemistry, and it has application in everyday daily life, that whatever product that we are using. So we can use the concept of physics and chemistry to create the nanomaterial, but for the application point we can use in different applications. For example, let me give you an example for each sector so that you can understand that how we can use. Let me start with biology, because often biology students get afraid that, oh, I don't like the physics, I don't like the chemistry formula, so that's why I choose the biology. So if you are in biology, nanotechnology has huge impact on biology. It started from food that we are producing through the agriculture sector. Then once we eat the food, we need the nutrition, so nanomaterial can help in that way. And if we have the nutrition and happy life, but if sometimes we get some disease, even it's very challenging disease like AIDS and cancer and various type of cancers, the nanotechnology greatly help in that. For example, the gold nanoparticle, the gold that we use as a jewelry, it has the different oxidation state, but similarly we can change the oxidation state and generate the gold nanoparticles. This gold nanoparticle has surface plasmon effect, and because of surface plasmon effect we can detect the cancer at very early stage. If we can detect the cancer at very early stage, it would be very easy to cure. Other than that, if we have the disease and we want to track that where this particular disease in body, or if you are taking a drug and you want to see the biodistribution, that where the drug getting end up, so this nanomaterial can help to detect the distribution of the drug in the body. The another important thing is, because nanoparticle has a phenomenon that we call surface area to volume size ratio. And if I tell you in simple terms, for example, you have a cricket ball or a simple baseball ball to play, and imagine that you have that ball of about 10 centimeter and you break that ball into billions of smaller balls. So you have the same mass, might be of let me rephrase my question, that you have a 1 kilogram of ball of 10 centimeter, and then now you break that 1 kilogram of ball in a billions smaller balls. So now you have the same mass, means same volume, but the size is more, the surface area is more, because you have more number of balls. So this is called the surface area to volume size ratio phenomenon, and because of that you just need a very small quantity of drug if you are using nanoscale principled or nanoscale material enabled drug. So you need very small amount of drug to deliver into your body, and then on the top of those small particles you can engineer in a way that they targetly go and only accumulate in a body part where you want to end up. Similarly, for the plant science, we use lot of fertilizers in agriculture, and we put this fertilizer in the soil. And if you see the reports, the scientific reports, we see that plant only use less than 30% of the fertilizer we put into the soil. And that is why you might heard in newspaper or read in watch in TV that excess use of the fertilizer they affect the human health, or these fertilizer get accumulate in the plant system and affect our diet, affect our health. So what this nanomaterial do? If we create a small particles of that fertilizer, these particles can efficiently uptake by the plants. So you require basically only in some milligrams with respect or in compared to 50 kilograms or 100 kilogram per hectare of the fertilizer. So you can imagine that how small quantity we require. So you can save the natural resources, you can save the energy, and you can efficiently produce the food. Now let's move to the another application that, for example, you want to go in the engineering sector, you want to do engineering after your class 12th, and how can you use the nanomaterial or the nanoscale technology. Using the engineering, for example, in chemical engineering or electrical engineering, you can use the nanoscale materials or nanoscale sensors to create the product or to create the chemicals or the sensing molecules they can sense at a very early stage or a very small quantity they can sense. For example, if these days there is a problem of that we call it chemical wars or a bio war, other than all this arm war that we call it nuclear war and so. So for the army point of view, if there is a battle and the opposite group or opposite party or some, like I will say that bad elements, if they use some chemical weapons, and chemical weapons are basically gases, and sometimes those gases they don't have the smell, so you can't recognize that there is a harmful gas or not. But there are small tiny nano sensors, they can basically detect those type of gases even at ppb level, parts per billion level, not in milligram or microgram, but at parts per billion level. So even if there is a very small quantity of harmful agent or harmful toxins, this nano sensor can detect that. So it has huge application. Even in computer science, you can make a small chips, even you can further reduce the small chips by making the nanoscale array and the pattern on the chips that we are using in our cell phone or in laptop or on the motherboard. The same way these days we are using the cell phone as an instrument, but we started to use like smartwatch, any other company, the smartwatch that we are using, the wearing band on our on our wrist, and we basically measure the several things other than the time. We also measure our body activity. This watch also gives us the information of our heartbeat, of our lifestyle, how long we sleep, how long we walk, how long we jump, how many steps we took in a day. So this gives all this information. But today I have a particular kind of device, but in future you will have a wearing belt, and the other person or the person where you will go, they won't be able to recognize that you have something or not. They are just like as your skin color, just mimicking like skin color. You will just do the hand like this, and the screen will appear on your hand, and you would be able to see that. And what I am talking, it's not a Hollywood film story. This is a real world story, the real world work that we do in the laboratory. And we have seen and we have created these things. We work in this field. So nanotechnology is a really exciting field, and the person having background in any field can use the nanoscale technology concept, and that is the beauty of this science, that interdisciplinary approach. Because now it is the time, because if we need to solve the global problem, and every problem is not a single reason. Every problem is associated with the multiple reason. For example, in every day you talk about air pollution or the air we breathe. The pollution is not because of a single reason. The multiple reasons are there. Some people use the cookie stove and they are emitting the coal emissions. Someone use the vehicles emissions. When we drive our vehicle, they put the sand on the road. The sand or the carbon particles from the sand, they come into the environment. If there is a strong wind, there is a lot of sand particles in the environment. So there are multifactorial reasons behind a single problem. So we need a science or scientific approach that can help or work together, work collaboratively to solve a global address. You want to get the admission for undergrad or graduation degree program for nanotechnology, to study the nanotechnology. So there are several institutes. If you talk in perspective of India, there are several institutes. They are offering these courses, mainly IITs and Indian Institute of Technology, that's IIT, and Indian Institute of Science, Bangalore. they are mainly offering several courses on nanotechnology. Of course, some other private institutes are also offering, but I'm not sure about their laboratory facilities and other faculties. If they have the good facilities, there certainly there should be or must be good sources. But certainly IITs in India and IISc Bangalore, or also the other institute that we call IISER, Indian Institute of Science, Education and Research. Those institutes offering several courses at undergrad level or the graduate level based on nanoscale technology or nanoscience programs. If you have the aim to move out of the country or move out of the boundary and want to create something great in collaboration with foreign institutes, I know most about the United States, so I can tell that major universities in the United States offering nanoscale science courses, nanoscale science and nanotechnology, and because it doesn't need a specific department, because this is an interdisciplinary science, so the existing department of physics, department of chemistry, department of biology or biotechnology, they came together and they created an interdisciplinary science that we call nanotechnology. And when you say that once you have a degree, where to go for the job, so you can get the job even at with the undergraduation degree or the masters, you can get the job in the industry as a process engineer or a nanotechnology scientist or nanotechnology R&D research and development associates. If you further want to explore your career and opportunities in the research program, you can go for higher education like PhD or postdoctoral studies. Even in India, I mentioned the institute like IIT, IISCR, IISc Bangalore, National Institute of Technology, and several CSIR laboratories, they providing PhD programs and postdoctoral fellowship programs, and also for biological application like NCBS, Tata Institute of Fundamental Research, and laboratories of ICR also and ICMR, they also offering courses on nanomaterial, mainly for the PhD programs and post PhD programs that we call postdoctoral fellowship. And also, if you want to explore outside India, you can see the website mainly for United States. I can tell it's a National Nanotechnology Infrastructure Network. You can simply search nano.gov, nano.gov, and you will see there are huge kind of resources for the education, for the opportunities, for the research programs, and for the everyday what happening in nanotechnology. You can get through a website that called nano.gov. It's an United States government organization website. Sometimes often question comes that what is the salary, and whenever I go somewhere, people ask me that what is your salary, and can I get more or can I get less. Of course, we need the money to sustain or survive our life and have a better life for us and our coming generations. More for that, I will tell you the digit, that how much digit you can get in your salary, but I would like to make a statement before that sometimes the money doesn't matter that what you are getting, but it matters that what you are creating for the world. Because what you are getting today is because of some scientist or some technologist, or there are several people who discovered something to make your life very easy so that you can access everything. So if you create something that will help the future, because what you are accessing today, these things discovered a long back. So what you are contributing, that is much more than what you get in terms of the salary. So let me tell you some numbers. It varies. If you ask me, in the US salary, if you go after the bachelor degree or master's degree, you can get the salary up to, it ranges from $70,000 a year, from $150,000 a year, and further it depends on type of your work, type of the industry, and type of your experience, that how much experience you have. And if you go after the PhD, your starting salary could be from $100,000 to $300,000 and more. It's up to your experience. And if we talk about the salary, that how the company give the negotiation and other things, it's solely based, mainly if you are going for industry, it based on what you know. It's not necessary that what is in your mark sheet, how much number you have. It depends on what you know and what you can do, and how you can solve a big problem, how you can contribute to this globe to address the global problems. So the question comes that I have done bachelor or masters, and I have not studied the nanotechnology so far. I studied somewhere biology or zoology or botany or geology or geography or chemistry or any other subject. You can name anything, but if you really want to use the nanomaterial or want to explore the nanomaterial application in your research, you can do it at any level. I can give my example that I have done masters in plant biotechnology, and then I did PhD in chemistry, where I started to use the nanoparticles, because I thought that can I create fertilizer particle in a very small particles and see the effect of small particle on the plant. And through that way it ignite my mind to work on nanoscale materials. So no matter at what stage you are, but you can use the nanomaterial for the application. Either you can create the nanomaterial using physics or chemistry concepts, or you can use the created nanomaterial for several applications in biology or in earth science or in geology or geography, etc. The personal or the students or researchers having background in nanotechnology or studied nanotechnology or having degree in nanotechnology can be recruited by scientific organizations, by the industry, and mainly the industry, if I mention, like applied material industries, chemical engineering industries, fertilizer industries, or polymer industries, and the computer or software based industries, where they create the models and the smart chips or the sensors to detect your touch, whether it is touch screen or detecting any chemicals, and also from the defense organizations. So I hope you enjoyed this conversation about nanotechnology, nanomaterials, and different perspectives. And if you have any question or comment, you can post your comments below this video. So I will see your comments and will respond, or you can email me directly. My email is Ramesh Raliya at wustl.edu, RAMESH RALIYA @wustl.edu, or simply you can search in Ramesh Raliya, Washington University, and you will find some detail there. And if students want to get admission in any university or need any kind of assistance, or want to have question related to career or what to choose in nanoscale technology or applications, whatever limited knowledge I know or my colleague know at Washington University, we would be happy to provide the resources and the guidance and assist all of you. Also, I would like to request the viewers to subscribe Daily Knowledge Track and get updated about science. I had conversation with the team of Daily Knowledge Track. They are really doing fascinating work to bringing out in-depth stories of science and technology and university, and what are the challenges and problems we face every day and what we see every day in our surroundings. These guys are doing really fascinating work, and I am very delighted to see this channel, and hope you all are enjoying all these videos. And please be posted and acquire the knowledge continuously and work hard and contribute to the society. Thanks for watching Daily Knowledge Track.